Hey everybody, Bill Sky, the Assembly Guy, and this video is a parallel of the one I just did on conditional branch instructions on x86-64 Intel processors in assembler language. This one will be for ARM processors. So it's going to be not too long of one, but it's going to be identical, except we're going to look at the differences in the instructions. So let's get started. So here we have a 64-bit ARM assembler language program, and I'm on an Intel Linux, but I have the compatibility libraries installed just as you should, unless you're of course using a Raspberry Pi. And the first thing that I did in the previous video is I just talked about how do you move around in a program in assembler language not unconditionally. You just say I want to branch over here or I want to go over here, right? Well, in C and C++, you would use a statement called goto, and then you would specify a label name. Well, in assembler, you don't say goto, you say branch. So this is what we call an unconditional branch. We simply say branch to that label name. And what I'm going to do is I'm going to make the label name right here, and it ends with a colon, and I'm going to put a couple of no-ops here so you can watch me branch around that. You can watch me branch around those two no-ops directly to that label, and I'm going to put a no-op there. So let's go ahead and build that. Built just fine. Let's take a look at the debugging. So I'm going to say make debug 1. I'm going to say make debug 2. And we're simply going to step through. Now, it's kind of hard to see this because when I did the interrupt 0 in the program, it executes the line underneath it, which is kind of a pain in the neck. So, but it's kind of good that I showed it to you because I'll show you how valuable no-ops are. I'm going to put a no-op right after that line. So what was happening was when I execute this line of code, it immediately executes this line of code, and then it jumped to here, but it was kind of hard to see that. So what I'm going to do is I'm going to put a no-op there, so after it executes this line of code, it'll automatically execute this one and it'll stop there. So we can actually see the jump occur. So we'll do the debug 1, we'll do the debug 2, here we go. Alright, so there we are in the branch. The branch is going to label name. Notice these other two no-ops there. Let me move this over. Those are the two no-ops under the branch. I'm going to step, and it jumped down to that branch. And if I kind of scroll up there, you can see the branch right there, and you can see the two no-ops, and that's the no-op for the label name. Label. So there you go. So that's what we call an unconditional branch. I don't remember if I called it that in the Intel video, but that's okay. All right. So let's continue this. Now let's do some branches based on the flags. So let's say I want to branch if the carry flag is set. And I'm going to go to carry flag set. Now, you don't know, the reason why you would do a branch of carry flag set is if you did something like this. If I loaded into X1, let's create a really big number here. If we load it into X1, all Fs, and then we add to X1 plus 1. That will branch, that will set the carry flag. Now you have to say add S, because S actually will say set the flags if appropriate. If you just say add, it won't set the carry flag. So let's go ahead and I'm going to put a no-op right here. And then I'm going to make the carry flag set label. Now I don't remember if I said, but a label is any name. It follows the variable naming standards within assembler language, except you have a colon at the end. All right. So what this is going to do is I'm going to fill up X1 with all zeros. I'm sorry, all ones. We're going to add a 1 to that, and that's going to set any flags if appropriate. And then we're going to branch to carry flag set if the carry flag was set. Now what's going to happen if you have all bits turned on in a register and you add 1, it's going to make that all 0 and you're going to lose a bit. And where does that bit go? That goes into the carry flag. So let's go ahead and make that. And so we have a little bit of a problem here because literals don't do well with load R. So what we're going to do is we're going to say move, and we're going to say equals. Or I'm sorry, hashtag. Let's see if that works. All right, that worked out great. All right, so let's go ahead and debug this again. Where is my terminal? There it is. I'm using Ubuntu today, so it's a little bit different. All right, so here we go. So we're going to go ahead and step through this. Here's our first no-op. All right, now we're going to fill up X1 with all those ones, and you can see it's completely filled up. Now we're going to add 1 to X1. X1 is now 0. Well, shouldn't it be a 1 and then all zeros? No, because that 1, there's not enough room in X1 to put that most significant 1 in there. So we're going to turn on the carry flag. We're now going to branch if the carry flag is set to the carry flag set label. So let's step through that. And now we're at the carry flag set label. Let's do the opposite. Well, maybe not the opposite. Let's take away one of these F's. So what that's going to do is that's not going to set the carry flag because not all the bits are turned on. And we can see how it does not branch. Okay, let's go ahead and run our code. Okay, we move all ones except for the most significant 4 bits are still zeros. We add 1. Notice we don't have a 0 there, but we do have a 1 in the most significant nibble. Branch of carry is set. The carry is not set. We're in the line after the branch, so it did not branch. So that's kind of how carries, you can jump based on conditions of the status flags. Now, there is a branch of carry flag set. If it's not set, you can see BCC. So this means that branch of the carry flag is not set. And this is an appropriate label name. So maybe we just change that to not. Okay, and then it will actually branch. So BCS for branch of carry set, BCC, branch of carry clear. That's what BCC stands for. Now this is unsigned. Okay, if it's signed, you want to check the overflow flag. And what I mean by that is if we move into X1, negative, I don't know. If we move into X1, what would be a good example for this? Branch on overflow. So let's put -1 into X1, and then I'm going to subtract and set the flags. X1, we subtract 1 from that. Does that work? What we're trying to do is we're trying to create a situation where we lose a bit in unsigned arithmetic. And I struggle with that a little bit. I guess what I could do is yeah, I'm having a little bit of a senior moment here. So it might be something like if you multiply 2 positive numbers and you get a negative number, the overflow flag will be turned on. If you add 2 positive numbers and you get a negative number, the overflow flag will be turned on. So if you're dealing with signed data, you will not use the BCC. Instead, you will use the BVS. And that's checking to see whether or not the overflow flag is turned on. So that would be for signed. To see if it's not turned on, you would do the BVC for overflow. Overflow is clear. So again, this is another reason why you as the programmer, you have to keep track of what kind of arithmetic you're doing. Are your variables signed or unsigned? You really have to keep track because you need to branch based on the signage, whether it's a signed integer, whether it's an unsigned integer. So that's basically it. Okay, so now let's do, what if we do 0? So let's I'm going to put the number 1 in there, and then I'm going to subtract 1 from X1. How do we branch if the result is 0? Well, I would say branch PL the zero flag set. So I move 1 to x1, I subtract 1 from x1, and I branch. PL is the zero flag is set. I'm going to branch to zero flag set. And let's debug it. I love those senior moments. All right, so let's move on here. Okay, so I move 1 to x1. I subtract 1 from x1. I'm going to branch if the zero flag is set, which is exactly it did. The zero flag is set. Label can be seen there. So the result of that was 0. Now earlier I said you want to use the S at the end of the sub. Watch what happens if we take away that S. Now remember, it branched because the zero flag was set. So I move 1 into x1. I subtract 1 from x1. I want to branch if the zero flag was set. And, oh, in this case it was set. So it might have something to do with overflow and carry, that if you don't have the S at the end of the sub, it won't set those flags. But it looks like right here, it did set the carry flag. Or the, I'm sorry, the zero flag. So yeah, that's something that's always confused me in ARM programming or ARM assembler programming, is that if you want it, sometimes you have to use the S at the end to say set the flags if appropriate, and sometimes you don't. It doesn't look like if it's a 0 result you need to do that because it's always set. However, if it's a carrier overflow, you really do need to have that S at the end of sub or at the end of add for those flags to be set. So we talked about the carry flag, the overflow flag. What about the sign flag? What if you have a negative result? So I'm going to put a 0 there, and I'm going to subtract 1 from x1, and I want to jump if that was a negative result. So I'm going to say BMI negative result. And this one I think we might want to test as well. All right. So I'm going to move 0 into x1. I'm going to subtract 1 from x1. And I think I should probably have a hashtag there. I'm going to subtract 1 from x1. And then if that should give me a negative number. So the negative flag should be set. And that's going to jump. That's what BMI does. So let's go ahead and build that. All right. Let's debug it. All right, so we're going to move 0 to x1. We're going to subtract 1 from x1. And we're going to branch if a negative value was obtained, and it did. Negative result was branched to. Again, if I move up a little bit here, you're going to see the other no ops. Actually, do I have no ops in there? I don't have no ops. That's why it branched, because I got rid of my little extraneous no ops there. Oh, silly, silly teacher. So I love making mistakes. So I'm going to go ahead and just put 2 no ops there. Now what actually happened? It didn't actually branch because these were not there. It just dropped down into that no op. So that may be why it looked like it didn't branch before. All right, let's try that again. Okay, looks good. All right, let's step through. All right, so we're going to move 0 to x1. We're going to subtract 1 from x1. Notice that there's not the sub s there. We're going to branch if the negative flag has been set. It didn't branch. Why didn't it branch? Because we didn't use the sub s. So let's go back here and put in the sub s. Oh, what a great fix. I love errors like that. So let's walk through this. All right, move 0 to x1, subtract 1 from 0, branch if the negative flag was set, and this time it did branch. And again, if you look up above, you can see that it went over these 2 no ops right there. Oh my goodness. So the 0 flag is probably the exact same way. You must have the add s, you must have the sub s to affect the flags. All right. Now let's do something else. Let's see if the destination is less than the source. So I'm going to move into x1 the number, I don't know, 100. And I'm going to move into x2 the number 50. Now what I want to do is I want to compare those, and I want to do like if x1 is less than x2. So I'm going to compare x1 with x2. And then I'm going to jump, I'm going to branch if x1, the register on the left, is less than the register on the right. So I'm going to jump to, I don't know, some label. Now don't forget those no-ops, otherwise we're going to be in the same situation. All right. So we load in 100 into x1, we load 50 into x2, we compare x1 to x2. If x1 is less than x2, we're going to branch to some label, otherwise we're going to do those no-ops. So let's see how that works out. Now is 100 less than 50? Nope. So it should not branch. Okay, we're going to put 100 into x1. We're going to put 50 into x2. We're going to compare x1 with x2. Is 100 less than 50? Nope. So it did not branch. It just went to the line underneath it. What if we want to see if it's greater than? So instead of BLT, what we can use is BGT, and that's branch if greater than. Let's make, now just FYI, this is signed. So signed is less than, greater than. Unsigned, unsigned is a little bit different. Unsigned is low, below, or high. So the left is higher than the right, or the left is lower than the right. So that's unsigned. We're going to get to that in just a moment. Okay, so we're going to look, is 100 greater than 50? Branch if x1 is greater than x2 to some label. Let's try that out. Should probably get rid of all that other code. Okay, moving 100 to x1, 50 to x2. We're going to pair x1 with x2. If x1, which has 100 in it, is greater than x2, which has 50, we're going to jump or branch, which we did. And we can see those extra no-ops that we went around in the jump. Now that was signed. Let's do those exact same things with unsigned. And I do have to change the label. I'm going to say unsigned. So now we've got the unsigned right here. And so instead of greater than, we're going to say high. Is x1 higher than x2? And these are unsigned, so the results should be the same. We're going to have to go through a bunch of code here. That's okay. Okay, so we're moving 100 into x1, 100 into x2. We're comparing them. We're going to jump if x1, which has 100, unsigned, is greater than x2, which has 50, and it did jump. And again, you can scroll up a little bit and see those no-ops that we went around. There's also greater than or equal to or less than and equal to. So I'm going to just put some comments in here. You can say branch if less than or equal to, and again this is signed, branch if greater than or equal to, and that's signed again. Now for unsigned, you have to, it's a little bit different. So let's come down here to our unsigned checks. And for unsigned, less than or equal to is branch if less than, same. I guess that's what that means. And again, that's for unsigned. Branch if, I believe it's higher. Yes, it's BHS greater than or equal to. And that's how I remember it. S stands for same. L is for lower, H is for higher, S is for same. And that's equal. On sign, you'll say less than, greater than, or equal. Okay, so one more. There's also not equal and equal. So not equal and equal are the same for both signed and unsigned. For signed, it would be break if equal, or branch if not. I said break. Branch if not equal. And that's exactly the same for unsigned, which makes complete sense. Now, one last thing I would like to do is I would like to show you the problem that can occur if you don't use the right branch instruction. So so we don't have to go through all of this code in the debugger, what I'm going to do is I'm going to move into x1 minus 100. I'm going to move into x2 positive 50. And then what I'm going to do is I'm going to branch if high. Okay, so I'm going to branch. Let me make sure that code's right. I'm going to branch if high. Yep, branch if hi. So if x1 is greater than x2, I'm going to branch to strange result. Now we know that negative 100 is not greater than 50, right? But we're not using the signed branches here. We're using the unsigned. I should be using greater than, right? But I'm using high. So I'm going to put a couple of no-ops here. And I'm going to make my label strange result. I'm going to put a no-op there, and let's see what happens. So again, I'm using the wrong branch. Conditional. Instead of high, I should be using GT for greater than. Let's see what happens. And we know that negative 100 is not greater than 50, but let's see what happens. So I'm going to move negative 100 into x1. I'm going to move 50 into x2. I'm going to branch if negative 100 is higher than positive 50. And did it branch? Oh, it doesn't look like it branched. That's interesting. It should have branched. So branch if negative 1 or negative 100. Oh, I didn't do the compare. Oh, that's why it's strange. I didn't do the code right. So I forgot to compare. So I have to say compare x1 with x2. Don't forget that compare. That's why it branched. All right. Okay, so let's do it again. Okay, moving negative 100 into x1, moving 50 into x2. We're comparing x1 with x2. If x1 is greater than x2, which it shouldn't be because it's negative 100, but we're using high instead of greater than, it did branch. There's the strange result label. And you can see the two no-ops we went over. So this is what happens if you use the incorrect conditional branch. Let's change this to greater than. That means signed. We're checking a signed number. Let's go ahead and debug it, and we should see that it doesn't branch because negative 100 signed is not greater than positive 50. All right, putting a negative 100 in x1, 50 in x2, comparing x1 with x2. We're going to branch if negative 100 is greater than negative or positive 50. It did not branch. We're right below the GT, and there's our strange result down here. It did not branch to that. So once again, it's very important to keep track of the signed, unsigned status of your data. So there you go. General branch instructions on ARM assembler language. Practice it. Try things out. I showed you how to use no-ops. I showed you how to create labels. And what we're going to do next are really cool if statements. We're going to take an if statement like from C or C++ or even Java. We're going to implement those in assembler language. We're going to do ifs, complex ifs, nested ifs, if else's or else ifs. It's going to be a lot of fun. See you there.